Okay, here's a video on proof strategy. This one's the reductio ad absurdum strategy. Sometimes I refer to it just as RAA, or sometimes it's referred to as an indirect proof. Just to note that this strategy is particularly strong because you can always use an indirect proof. A direct proof, or like a straightforward proof, goes directly from its premises and proves its conclusion. But an indirect proof tries to show that if you assume the opposite of the conclusion, you're going to run into a contradiction, right? And so that contradiction is that absurdity. This basically means reduced to an absurdity, reduced to a contradiction. So that's the strategy. You assume the opposite of what you're looking for, and because you have a hunch that what you're looking for is correct or is true, assuming its opposite must lead to some falsehood. And so if you know that for sure, you're definitely sure you'll find a contradiction when you do the assumption of the opposite. Okay, so let's start off. We'll do De Morgan's law. We'll do it from this direction. Not A and B entails not A or not B. So the strategy starts off like this. Right? We have one premise. Right? And so we said that we're going to use reductio ad absurdum, which means that we're going to assume the opposite of what we want and then try to prove a contradiction. Here it's particularly useful because, as you can see, you can't really get a disjunction anywhere from your premises. Your premises just includes a negation. And so it's really hard to work with. And so what we have to do is try to produce this formula. But if you think that you can produce it by negation, not negation, disjunction introduction, you're going to get stuck. And so we're going to try the reductio ad absurdum. So the opposite of this formula is not A or not B. And that's assumed, right, for reductio ad absurdum, but I like to write negation introduction, which, as I said before, the reductio ad absurdum method uses all the negation rules. So here this is 2. So now you may be stuck again, but you sort of have to think through this. I know that this is going to produce a contradiction somehow. And what I want is to produce a contradiction that will then let me negate this, right? And so you think to yourself, how am I going to produce a contradiction? If you assume the opposite, you know there's a contradiction that's going to come up. And it's probably going to be between either your premises or your assumption. Here, if you can see, it's pretty complex, but if you're used to the rules, you'll be able to see that you can produce contradictions from this. So I'm thinking that you're going to get a contradiction from this and the negation of this. So not A and B will produce one of our contradictions. And not A or not B will allow us to produce more contradictions. So let's first try to produce a contradiction in order to negate our assumption, right? And so I'm going to try to make A and B in order to produce my contradiction. So how am I going to get A? Right, and so if I want A, I'm going to again use the reductio ad absurdum to try to produce that. So I'm going to assume the opposite of what I want, and what I want right now is A, right? And so I assume that from negation introduction, for negation introduction, I'm sorry. Okay. So once you get the assumption of not A on line 3, hopefully you'll see that you can produce a contradiction to again get A. So here, if you assume not A can create not A or not B for you, right? And that's from 3 or introduction. So or introduction, just a little bit on or introduction. Since we know, or rather we assume that not A is true, right, from the truth of any formula, right, its disjunct must be true. We don't know whether not B is true or false, but that doesn't really matter, because as soon as you know one of the disjunct is true, the whole disjunction becomes true. So that's a sort of mini explanation of or introduction. Okay, so on line 5, we have our lambda, because the contradiction comes from 2 and 4. That is negation elimination. So that's from 2 and 3. And then on line 6, we said that we can produce A from the contradiction. So that's what we're going to do. And we're going to produce A by negating not A. Right? And so that's 3 and 5. Negation introduction. Sorry, my brain is blanking. It's 2, right? Because 3 is 3, and then 5 is 2 and 3, but we discharge 3, and so you only get 2 as the dependency number. Okay, so on line 7, we can get A by double negation on 6. Then on line 8, what we have is, right, we have A, now we're going to try to get B. Again, you use the strategy of reductio ad absurdum, and so you assume the opposite of what we want, right? And so the opposite of what we want is B, right? And so we try to produce B by assuming the opposite, so that we can use this strategy to produce B. So on line 9, we do the same thing, right? So from here, not B, you can see that we can get not A or not B from 8. Same rule, or introduction. So 8. Then 10, it contradicts again the same assumption that we made, right? If we assume that the opposite of our conclusion is true, then it's going to produce a lot of craziness. So here's one of the craziness that happens. Okay, where was I? Okay, 2 and 9. Negation elimination. 2 and 9 is 2 and 8. So on the next line we negate B. So that's negation intro. 8. Oops. 10 and 8, 8 and 10. That's okay. And so we discharge 8 here, and so it should be just 2. So if just a crazy note, if you assume that the conclusion is false, right? That means its opposite is true. Then what this produces is A and B, right? So here B comes from 11, double negation. So now that we have A and B, what we're doing is going to produce the last contradiction that we need. So on 13, we can combine A and B, right, from line 7 and line 12, and introduction. That comes from 2, and we produce the contradiction again, right? And the contradiction comes from now 13 and 1. So that's 1 and 2. Right, so 1 comes, or depends on 1, and 13 depends on 2, so 14 should depend on 1 and 2. Okay, with the last contradiction, we now get to discharge our assumption that we started with. Right, so we place a negation into that formula. It's from 2 and 14. Negation introduction. And here, because we're using negation introduction with this line, we're going to discharge it because this is a discharging rule, and our note says given if you use this line with negation introduction, you're going to discharge it. And so this should just come from 1. And so on line 16, we use double negation to produce not A or not B. So here, not A or not B comes from 15, double negation, right, and depends only on 1. So we've just proven that not A and B entails not A or not B, right? And this is how we did it. It's an indirect proof, they call it, because we didn't go from not A and B directly into not A or not B. What we did is we assumed the opposite was true and then showed that there was a contradiction. And so given that there's a contradiction, we are going to say that our assumption is false, is wrong. Okay, just a few notes on why I write negation I instead of reductio ad absurdum. Negation I helps you to sort of see that you're going to discharge these assumptions by using negation introduction. And of course, to use negation introduction, you're going to need to find contradictions, right? And so if you assume one formula to show that there's a contradiction, you're going to need one contradiction here, right? And then if you're going to assume another formula and try to negate that using the same sort of strategy, reductio ad absurdum, you're going to need another contradiction. So that makes two contradictions. Then likewise, here we did the same sort of strategy, and we need to show another contradiction. So here you've gotten three assumptions using the same strategy, so you're going to need three contradictions. And so you could sort of see that here we've produced 1, 2, and 3 contradictions. And also, given that this is the assumption that gets discharged with this this rule, if it's used elsewhere, you won't discharge it because it's not a discharging rule, right? And so here you can see on line 2, we've used here, but 2 remains in the dependency number because this is not a negation introduction rule, right? So on line 6, we did use a negation introduction rule, but we used it with 3, which says that if you use this formula on line 3 with this rule, negation introduction, you're going to discharge 3. And so that's what happened on line 6, where 3 gets left out in the dependency numbers. And so hopefully that's should start to see the structure and the pattern of reductio ad absurdum, and of course the notes for the assumptions. Hopefully that helps, and we'll do more difficult problems in a little bit. Okay.